All right, so we're going to pick up where we left off. We're going to solve another inequality. This time, down at the bottom, we're going to solve a betweenness inequality. All that means, as you look at this, is in addition to having the 5x plus 3 less than or equal to 20, it's bounded on the lower end as well. It's also greater than -2. So it's both of those things at the same time. There's absolutely no difference here in solving. So if you haven't done one of these before, don't get too stressed. I'm going to cover up this end of the inequality right here. If I gave you this problem right here, 5 plus 3x is less than or equal to 20, what would you do to both sides of that? Subtract 5. Yeah, so here's what you're going to do. Now that I have that other side, we're going to subtract 5 over here as well. Okay, you do the same thing on both ends of the boundary. We don't change our inequality signs for subtraction, only if I'm multiplying or dividing by a negative. So on the left, -2 minus 5, that's -7. Going to leave the less than. Here, the 5's cancel. I have 3x in the middle, and then less than or equal to 20 minus 5 is 15. Same thing is true with this second step. To get the x by itself, I'm going to divide by 3. I'm almost 100% positive everyone would say that. So when I divide by 3, I do that now on all parts of this inequality. So I divide by 3 on the left, I divide by 3 in the center, I divide by 3 on the right. And now I get my boundary of answers that would have satisfied the original inequality. The lower bound of this is -7/3. I did not divide by a negative, so I'm going to leave my inequality signs the way they are. In the middle, I've got my x. And then on the right, 15 divided by 3, that is 5. Inequalities, I always write in interval notation, so I'm going to do that. My lower bound is -7/3. My upper bound is 5, and then parenthesis over here because there's no equals. And then because of the equal at the 5 end, we put a bracket. Okay, hopefully none of that is big news to you. Before I give you your problem due, any questions, comments, concerns about that problem right there? All right, then do the exercise that's right next door, please. Okay, once again, I got 2 steps on this problem. So what's the first step? What do I need to do to solve this? Add 2. Sure, I'm going to do that to all the sides. So add 2 there, add 2 in the center, add 2 on the right. And so when I do that, now what I have on the left is -6. Again, adding does not change my inequality signs, so I'm going to leave those alone. The -2 plus 2 in the center cancel, and I have 4x. And then on the other side, 14 plus 2 is 16. Everybody doing okay? Any questions? And then step number 2 is I'm going to divide by 4. So my interval looks like this. On the left, -6/4 reduces to -3/2. In the middle, the 4's cancel. I'm left with x, and that pen is dead. So I got a new one. And then 16 divided by 4 is 4. I'll write that as an interval. All my pens seem to be just tragically dying on me here. And so now what I will do is write that in interval notation. The lower end of the interval is -3/2. The upper end is 4. What did you put at the -3/2 end of the interval? Parenthesis. There's no equality there. What did you put at the 4 end? Bracket. All right, great. Good to review all these things because they're going to come up over and over and over again. All right, I'm going to flip the page. If you got a question, ask it. Be involved in your education. On the next page, exercise 6. It's just another inequality. I just put some fractions on there so that we could review that again. So go ahead and give exercise 6 a try, please. just to give everybody a nudge, remember, because we talked about this last time, our goal is to clear those fractions. I don't want to have to deal with them. So what are you multiplying every term there by? Common denominator, 14. Okay, so if you didn't do that, go back to the drawing board. If you did, keep working. I'll give you another minute or so to finish your progress. We're going to multiply every term here by 14. All right, so the first term, I've got 3x over 2. I'm multiplying by 14. What does that term become when all is said and done? What was that? 21x, sure. And the way we get that is 2 goes into 14 and leaves me 7. And 7 times the 3x that's already there is 21x. Great job. Plus, the next fraction is 4x over 7. I multiply by 14. What's the end result there? Yeah, sure. 7 goes into 14, leaves 2. And the 4x times the 2 is 8x. Remember, whenever you have a fraction, I know we hate fractions. Our goal is to get rid of them. Okay, so hopefully you multiplied by something and you have no more denominators. And then greater than or equal to, and I can't forget to multiply the other side by 14 as well. And so that turns out to be negative 70, I believe, if I'm doing my arithmetic right. Just about done. 21 plus 8 is 29x. I'm going to divide by that 29. It is not a negative. It's a positive, so I'm not going to flip the sign. I'm just going to have x is greater than or equal to negative 70 over 29. This tells me all of my values are bigger than or equal to this. So is this fraction the lower boundary or is it the upper boundary? It's the lower. Because everything is bigger than that. Remember, if you need to draw a number line, I know we're visual processors. That is a great thing to do. Either way, you should have the interval with a bracket and our fraction going to infinity. Questions about that? All right, we'll go ahead and example 5, the next one. Go ahead and take a second and solve that equation, please. I don't want you to get too in the weeds on this. I have a purpose for this example. So I'm going to get started. If you're working, still keep working. If you got to a place and you don't understand what's going on, that's okay. That's the purpose of this example. So on the right side here, I'm going to distribute that negative. So I've got 5x and a negative 9 and a negative 9x. And then I'm going to collect those like terms. So 5 minus 4x is equal to 5x minus 9x is negative 4x and then minus 9. I'm going to follow my usual procedure and get all my x's on one side, numbers on the other. And here's what happens when I go to get my x's all on the same side. What do I notice happens? They cancel on both sides, right? So I'm not even going to worry about the numbers. So when I go ahead and I add this up, on the left side of this, I've got a 5. The 4x's cancel here. I've got my equal sign in the middle. The 4x's cancel here, and I've got negative 9. All right, so here's the thing that happens. This is one of our special cases when our x terms cancel out. Is this a true statement? Is 5 equal to -9? No, there's no variable there. That can never be true. Okay, so this is called a contradiction. Okay, and what you need to know about a contradiction is that there's no solution. There's no x value that will ever make that true. And so the solution here is that there is no solution. And in our class, when we have no solution, that means my solution set is empty because there's nothing in it. The symbol I will use is I'll use my braces with nothing in between them. I don't remember if I've mentioned it in this class before. There is another symbol. If you prefer it, that's great, but just use one or the other. You can use the null symbol, which is a circle with a toothpick through it. Okay. But just pick your favorite, either the empty set braces or the null symbol, and use it, and there you go. All right, same or a similar thing's going to happen on exercise 7, so I'm not going to bore you with all the details, but let's just go through solving this, and we'll see what happens. Yes. I'm sorry? That's a great question. In case you didn't hear, are you supposed to put the null symbol in the braces? And here is why the answer is no. The null symbol means an empty set. The braces with nothing in them means an empty set. So if you were a set theorist, that's what I majored in when I was in college, if I put the empty set in the braces, is that set empty anymore? No. So that I would understand what you were trying to communicate, but you would be using bad math lingo. So do not use both. Okay, pick your favorite and go with it. Great question. I really appreciate you asking that. Okay, so exercise 7, let's go ahead and distribute. I've got 3x plus 6, then minus 5x minus 10. When I click those like terms on the left, the 3x minus 5x, that's negative 2x. The 6 minus 10 is negative 4. At this point, I'm sure if you're still awake, you could see what's going on here, but I'm going to take one more step. I'm going to get all my x's on the same side. I'm going to take this negative 2x. I'm going to add it to both sides. And once again, we get the special situation where my variables cancel. I no longer have any x terms. And so what I have left on the left side of this is negative 4. What I have left on the right is negative 4. But I have a little bit of a different conclusion on this one. Now, is negative 4 equal to negative 4? Yes, thank you. Thank you. I appreciate the 2 people that affirmed me in that. Yes, negative 4 is equal to negative 4. This is always true. This is called an identity. And the conclusion that you come to with an identity is no matter what x you had plugged in back at the beginning, you're always going to get a true statement. And so the solution here is all real numbers. And when we talked about interval notation, I mentioned to you how we write mathematically all real numbers. Anybody remember how we do that? Perfect. Thank you. Negative infinity to positive infinity, the whole number line. That's how we notate all real numbers. Okay, so you might come across those special situations in your homework or on the test or somewhere else. It's good to just be able to distinguish the 2 of them. All right, so the last thing for our equation and inequality, this, in all honesty, might be the most important thing that we do in this section, just because, as I've mentioned before, in this class, our ability to read and interpret graphs is going to be paramount. Okay, so we are going to use these graphs that I've given to solve equations and inequalities. So looking at this right here, this is example 6. We're going to use this graph to solve the 2 statements. Let me also notate one other thing because I forgot to do it on my picture. We're going to call the blue line, that's going to be f of x. And the red line, that's going to be g of x. Okay, just so that we have those labeled properly. All right, so the first thing I want to do is I want to know where is f of x equal to g of x? Well, physically, where does that happen? Where is the function f equal to the function g? What's happening at 2, 3? They intersect. Great. Yes, they're equal. They have equal values where they intersect. And yes, you've correctly identified that as the point 2, 3. Here's how we answer the question. We now know where the y values are the same. The y values are the same at this point that I just made a green dot at. Okay, that's where my values are the same. What x value, what's the input that produces those equal y values? Say it like you mean it. 2, yes. Okay, so the answer here is going to be 2. That's where those two things are equal. Anybody not seeing that? All right, well, before we do the inequality part, I would like you to go over to the exercise right next door. And I would like you to do, where is f of x equal to g of x? And once again, let's let the blue graph be f of x, and the red graph will be g of x. All right, again, just to remind you, our function notation, when you see it, this notation right here, f of x, the same thing for g of x, that means my y value. Okay, that's how function notation was defined for us. So where are those y values equal? Again, right here where the two graphs intersect. So what is the input that produces those equal y values? It's what? -3. Yes, I appreciate that enthusiasm. It's awesome. Okay, we good so far? All right, the next one. I'm going to go back to my first graph. I want to now know, where is f of x bigger than g of x? Meaning, where are the y values associated with the function f? Okay, where are those y values bigger than the y values associated with the function g? Okay, so here's where they're equal, the green dot. So which way would you hypothesize? Are the y values of f bigger on the left of that intersection, or are the y values of f bigger to the right of that intersection? Which side? To the right. Notice, my function f is the blue graph. These y values right here are bigger than these y values of the red one. Pick an x value. For instance, let's just say I pick this x value. The y value of f is clearly bigger than the y value of g. Is everyone tracking on that? Because sometimes this is a stumbling block for students, and I want to make sure I'm doing an at least adequate job of explaining it. So we need the values on the left. So what I'm going to do is I'm going to say, okay, these x values that I'm highlighting green down here, these x values are the ones that produce the y values of the blue graph to be bigger than the y values of the red graph. And so I'm going to write this in interval notation. That happens from -infinity all the way up to 2. I'm going to put a parenthesis at the infinity side because that's what I always do. And what am I going to put at the 2 side of this particular interval? Why a parenthesis? You're 100% right. There's no equality right there. So I use a parenthesis right there. All right, give it a try. On exercise 8, identify where the y values associated with g are bigger than the y values associated with f. Yes. What I mean by putting the y under there is when we first introduced function notation, or at some point in the past when you first saw function notation, your instructor, and I wrote this the other day, said function notation is y is equal to f of x. This notation, f with the parentheses x, that's just another way to represent the y values. Okay, so then we say, okay, what's the input? What's the x value that produces that y value? So what I was just trying to notate here was when you see f of x or when you see g of x, that's causing you to look at the y values. That's the comparison being made. And then the solution is the x value that produces those equal y values. Okay, a little better? Okay, keep trying, work through. So go ahead and do the inequality of exercise 8 if you've not yet done it. Okay, so this time I want to know, where are the y values associated with the graph of G, which is the red graph? Where are they bigger than the y values for F? So here's where they're equal, this dot right here. So left or right, which way has the values of G bigger than the values of F? To the right. Yeah, let me just pick an x value. So just to show, here's an x value to the right, like you said, and the value of G associated with that x value is bigger than the value of F associated with that x value. Okay, so good. You picked the proper side. So now I need to notate the interval that is producing those y values. So the interval starts here and it goes in this direction, just like you said, it goes to the right. So that means the interval starts at -3. That's the first x value, and it goes to infinity. And once again, since there's no equality here, I'm going to put a parenthesis at the -3 end. All right, one more problem, and then we are going to wrap up this section, and we will go to the last one down here, exercise 9. Once again, let's let the blue graph be f of x, and the red graph be g of x. All right, so once again, I want to know, first comparison, where are the y values equal? Where is the function value of f equal to the value of g? And what x value produces those equal y values? 0, yes, that happens right here where the two graphs cross. So the solution set there is the set with 0 in it. Great. So now the next comparison is, where are the y values of f less than or equal to the y values of g? So where are the values of f below the values of g? Does that happen to the left of that equal point or to the right? To the right, yes. So again, just in case you're having trouble seeing it, here's just an x value to the right. And so the value of f is down here, the blue graph, and the value of g is up here. So f is less than the value of g. So that happens to the right. So this is going to be my interval right here on the x-axis. So that starts at 0. Goes to infinity. This time, though, what am I going to put at the 0 end of the interval? A bracket, because I do have an equal bar right there. So that changes that end of the interval. All right, that is the end of section 1.5.